Okay. Good evening. Can you hear me? Can you hear me? Okay. Good evening. Uh, okay. Okay. This is actually extra class. I'm going to complete our electricity lesson today. Yeah, electricity lesson. I last week theory part completed. We discussed transformers and electricity bill calculation last Wednesday. No. Okay. This is the and I given homeworks. Yeah. Let's go to homework. I given 3 homeworks. No. I told to complete the 2015. What is the question number? As I remember, 9. 2015 question number 9. Uh, what's the question number, Fatima? 9. Okay. This is a question. Not 9. 9 is not electricity question. No? Yeah, it is work energy. 10, 10, 10. I told you to complete the electricity question. Ida number එක මාරුනක් දන්නේ. I want to discuss this electricity question. The previous question from Dihini, what you complete the question in 2015 paper? 9 or 10? 9 එක කරන්න බෑ තාම නේද? Yes. Question number 10. හරි. Okay. Yeah, part A. A potential difference V is supplied across an electrical equipment and a circuit. Sorry. A potential difference means voltage is supplied across an electric equipment and a current I flow through it. Write down expression for the rate of energy depression of the equipment. Okay, what's the meaning of rate of energy depression? Rate of energy depression, can you send me another name for rate of energy dissipation? Rate of energy dissipation. Another name? Anyone? The rate of energy dissipation. වෙන නමක් කියන්නේ ඒකට? Kabir? Another name for rate of energy dissipation? Power. Very good. The power. The rate of energy consumption. That's power. Okay, power, what is the equation? The V and the voltage difference, the potential difference V and current I. Okay, what is the equation? P equal V I. Very simple. This is the basic equation, right? P equal V I. That's the first answer. Very simple. Okay, who correct this? Dehini, correct? P equal Vi. That's basic equation that we discussed in the theory lesson. Okay, part 2. A current I flow through a resistor R. Through a resistor R. Write down an expression for the rate of heat dissipation. The rate of heat dissipation, again, rate of heat dissipation also power, right? The heat is energy. P. It is given P. Across the resistor R. Okay, P equal Vi is the basic equation. P equal Vi. P equal Vi is the basic equation, but we can modify this equation by with R. According to V equal IR equation, Ohm's law, V equal IR, P equal I squared R. P equal I squared R. This is the answer. This is the answer. මෙයාගේ V වෙනුවට I used instead of this V, I applied IR. IR into I squared R. Correct? Okay, that's the first part answer. That's the second part answer. Correct? Try stand. හරිද? දෙහිනි? සර්මියා? Is it correct? Correct. Fatima? Correct. First two parts. Dehini? හරිද? They are exam questions. Very simple. Very simple. The basic theory parts are. Okay, let's move into question part 2. P. The voltage of a national electric supply of two countries are 240. 240 mean like Sri Lanka. And 120. Europe countries, normally 120 is the electricity supply. Two electric kettles rated 240. Two electric kettles. The first one, it's rated 240 and 1 kilowatt. 240 and that means supply voltage and the power. 1 kilowatt means power. The second kettle, 120 voltage is a supply voltage and same power, 1 kilowatt, 1000 watt, are connected to 240 and 120 volt supply voltage respectively. Then connect kalla deyanne. Find the current flowing through each kettle. Find the current flowing through each kettle. Okay, how to calculate? Part B. Part B. How to current flowing through this part? Okay, think first kettle, kettle number 1. Kettle 1. P equal VI. P equal VI. This is a, okay. Now what is the power? What's the power? 1 kilowatt, 1000. 1000 equal. How about voltage for first one? Supply voltage 240. 240 into I. Okay, now you can isolate the 0 to 0 cancel. 100 over 24. What is the current? 100 over 24. 100 over 24. Quickly, I need your answers. 4.166. 4.166. 4.166 ampere. Okay, let's move to kettle number 2. Kettle number 2. P equal VI. The power same 1000 watt. 1000 watt. 1 kilowatt means 1000 watt. Voltage 120. The current I 0 to 0 cancel. 0 to 0 cancel. 100 over 12. 100 over 12. 8.32 window. What's the current? Eight point three three. Yes, 8.33 ampere. 8.33 ampere. Okay, they are the current flow in two kettles. Current flow in two kettles. Very simple. Ne? Very simple. They are the exam questions. You only need to know basic concept. Then you can apply. All right, let's move into question number 2. If conducting wires with same resistance are used to connect the kettles to the main supply. If conducting wires with same resistance, yeah, connecting wires, that means voltage supply wires are same resistance, are used to connect the kettles to main supply. Explain the which circuit generate more heat. Explain which circuit generate more heat. Okay, how to calculate the amount of heat generate? The amount of heat generate, how to calculate? Two wires, same resistance, same resistance. Now you can see you need the air current density knowledge, right? You already know current density. BST class 830. Who is it, sir? How is sir? Hemant. Okay. I'll inform. ඔයාලා යන්න 9ට මං කියන 9ට පටන් ගන්න. Dehini, you also have, right? Okay. Okay, 9ට පටන්. Okay. Okay, now you have to think. If conducting wire with same resistance are used to connect both cables to the main supply, explain which circuit gets more heat. That means which wire more heating. Okay, now you need which knowledge? Current density knowledge. Okay, see what is the current density? Current density. C part, not part 3, no? B part 3. Okay, you need current density knowledge. According to current density, you can explain now. What is the meaning of current density? Current density equal the current flowing through a unit area. Sorry, current flowing through a unit area, unit cross section area. The current flowing through a unit cross section area. Current flowing through a unit cross section area. Okay, when increasing the current, what happened? The current density increasing. Current density increasing, what happened? The heat generation is increasing. Then you can say the second kettle produce more heat. Second kettle, or you can say 120 volt kettle. The reason you can say the connecting wire, the supply wire transfer greater current, supply wire transfer current greater than first kettle. Then it has more current density then it has more current density than first kettle. Then first kettle. Okay, could you understand the reason? Second kettle is produce more heat. The reason, high current density. The current density of second kettle wire greater than first kettle, because the current same resistance same resistance. Same resistance. Okay, VST class, okay. Okay. Is it understood? Second kettle, Dihini, Samya. Yeah, due to high current density, second kettle supply wire heat production is greater than first kettle. Fatima got second part? Kabir, correct, right? Okay, third one, suggest a method to reduce the energy loss. Energy loss means heat production. To reduce the heat production of a circuit mentioned above part. That means second kettle. consider that the supply voltage cannot be changed. We can't change normally. Supply voltage change cannot. It's a huge process. We have changed all wiring system. That's not practical. We can't change the supply voltage. We can't change. We can't change the supply voltage. Okay, what are the methods? Okay, what's your suggestions? Can you send me? What are the suggestions? Deni? Any idea? Okay, what is the requirement to reduce the heat loss? To reduce the heat loss mean to reduce the resistance, no? If we can reduce the resistance, yeah, if we can reduce the resistance, yeah, we can use less resistance wire. That's okay. We can use less resistance wire. Third one, we can change the supply wire with less resistance. Low resistance wire का use करना पड़ा. Okay, what else? What else more practical suggestions? Abhi? We can use another one very good. Yeah, we can increase the thickness or cross-section area of the, according to our current density knowledge, we can increase the thickness. We can change with higher thickness, that means high cross-section area supply wire. Increase the cross-section area of or thickness, cross-section area or thickness of supply wire. Supply wire. Okay, they are the most practical suggestions. Okay, I think you can remember the R equal rho L over A. The resistance and length directly proportional. The resistance and cross-section area inversely proportional. Therefore, when you increase the cross-section area, what happened? The resistance, when you increase the cross-section area, the resistance getting decreasing. Okay, both answers correct. Both answers correct. We can increase the thickness of cross-section area, or we can change the supply wire into less resistance wire. Understood? Okay, they are the more practical suggestions. If not, see the current density equal the current over cross-section area. When you increase the cross-section area, what happened? When you increase the cross-section area, the current density getting decreased. Then what happened? The heat generation or heat production, energy loss will be decreased. Okay, that's a full idea. I think now you got full idea. Kabir, understood? Fatima? Okay, two houses situated at a distance 1 kilometer from two electricity distributing centers. Yeah, both houses 1 kilometer distance. Two electricity distribution centers of 120 and 240 voltage as shown below. Copper and aluminium wires of cross-section area 8 into 10 to the minus 6 square meter can be used for transmission of electricity. Can be used to electricity transmission. The resistance of copper is the resistivity, sorry, the resistivity, that means rho, the resistivity of copper is given, and the density of the wire is given, the density also given, and these values are aluminium resistivity and density also given. This is a copper resistivity and density, this is aluminium resistivity and density. Are okay. Using given data, calculate the resistance and mass of copper and aluminium wires are used. Okay. Now think distribute 1 kilometer from electricity distribution center of 120 and 240. This is the first one, 240 this one. Copper and aluminium wires of cross section area same can be used to use for the transmission of electricity. Yes. The resistivity of copper and density given, the resistivity of aluminium and density given. Very simple. All data are required for this calculation given in the above part. Using the given data, calculate the resistivity and the mass of, sorry, resistance and mass of copper and aluminium. First one, part C, part 1. C, part 1. Okay, what is the resistance? The resistivity given, right? The resistivity given, then R equal, then first copper, R copper R copper equal rho L over A, rho L over A, rho L over A. Okay, what is the copper resistivity? Copper resistivity 1.7 into 10 to the power minus 8. 1.7 into 10 to the power minus 8. 1.7 into 10 to the power minus 8 ohm meter. Into, how about the length? How about the length? It is 1 kilometer. 1 kilometer into 2. 1 kilometer means 1000 meter. Then how many wires? 2 wires. According to the diagram, it has 2 wires, no? Wires dekak thiyena. Then what is the distance? What's the length of the wire? 2 kilometers. 2 kilometers means 2000 meters. 2000 meters. 2000 meters. The cross section area is given. The cross section area 8 into 10 to the power minus 6. 8 into 10 to the power minus 6. 8 into 10 to the power minus 6 square meter. Okay, now square meter to square meter cancel out. Now 10 to the power minus 6 to 10 to the power minus 8 cancel out. Minus 2 remain. Minus 2 remain. 1.7 into 2000. Can you get 1.7 into 2000? Or 17 into 200 mean? Wait, 17 into 200 mean 34. Into 10 to the power minus 2 over 8 is the answer. Ohms. Ohm is the remain. Ohm make it through. Now 34 over 8. Now it is 10 to the power minus 2. Now 20 cancel out. 20 cancel out. 34 over 8 is the answer. Ohms. What is the answer? 34 over 8. 34 over 8. Kabir, what is the answer? Samya? 34 over 8 is the answer. Yes, 4.25. Very good. 4.25 ohm. Understood? Simple. This these factors and equations we discussed in the lesson, right? R equal rho L over A. Directly they in exam questions directly they have asked what is the resistance, the resistivity, the length, cross section area, everything given in the question. Okay, now same method for aluminium also. Now second one. Not this is a resistance. Again, it is asked what is the mass. Okay, you already know the density equal mass over volume. Mass over volume. Mass over volume. Mass over volume. Okay, how about the density? The density of copper given. The density of the copper. What is the value? The density of copper 8,900. 8,900. 8,900 kg m squared. Mass over. How to get volume? Can anyone send me any method to calculate the volume of this conductor supply wire? Okay, how about the shape of the volume? Shape of these conducting wires? It just like a small cylinder, right? Small cylinder. Now, cylinder is a uniform object. Now, how we can get the volume? We can get the cross section area multiplied by length. හිතන්න තියෙන්නේ cross section area multiplied by length. Okay, what is the cross section area? 1.7. No, cross section area 8 into 10 to the power minus 6. What is the length? 2000 meters. 2000 meters. Okay, now you can isolate them. M equal. Okay, can you get this answer? M equal. Methana 30. Now cross multiplication and 5 zeros. 5 zeros to methana minus 6 cancel out. It's come as minus 1. Then 89 into 8 into 2. Can value 89 into 8 into 2. Take the value of 89 into 8 into 2. Quickly send me 89 into 8 into 2. Quickly. You don't have time. $89 into 8 into 2. Kabir? $2,000 the distance 1 kilometer. Distance 1 kilometer. According to the figure, it has 2 wires. 1 kilometer means 1000. Now 2 kilometers. 2 kilometers mean 2000 meters. Okay. Yeah, 1400. Yes, 1400. Yeah. Answer 1042.4 kilogram because 10 minus 1 you can use calculator. If you don't clear these cancel out zeros, you can use just calculators and cross multiply. However, this is the answer. This is the mass of copper. Understood, Dini? Okay, now same method for aluminium wires. Aluminium wires as well. Okay, same method for aluminium. Okay, how to get the resistance of aluminium? R equal rho L over A. What is the rho? For aluminium, what is the rho? 2.5 into 10 to the power minus 8. 2.5 into 10 to the power minus 8 ohm meter into L. The length 2 kilometer. 2 kilometer means 2000 meters. 2000 meters. The cross section area. The cross section area same, right? 8 into 10 to the power minus 6. 8 into 10 to the power minus 6 square meter. Now square meter to square meter cancel out. Square meter to square meter cancel out. 10 to the power minus 6 to 10 to the power minus 8 cancel out. Minus 2 remain. Now minus 2 to 2 0 cancel out. 2 0 cancel out. Now 2.5 into 2.5 25 වෙනවා මේ 0 එකත් අයින් කරමු අපි 25 into 2 50 over 8 50 over 8 50 over 8. Okay, if you can't understand my calculations and cancel out things, you can use calculator, no any issue. Okay, you have access to it, use calculator. Okay, 50 over 8. What's that? 50 over 8. Hmm. 6.25 ohm. 6.25 ohm. Ohm nitruin? Ohm. 6.25 ohm. Okay, the same method, the density equal mass over volume. The density of the aluminium given, the density of aluminium 2800 kgm squared, 2800 kg m cube, sorry, not m squared, not m squared, m cube, okay, m cube. Mass, don't know. How about the volume? How about the volume? Cross section area multiplied by length. This is a cross section area 8 into 10 to the power minus 6 multiplied by 2000. 2000. Okay, now 10 to the power minus 6, 3 0 cancel. Cross multiplication. Methana 5 zeros cancel. Then 10 to the power minus 6 can convert into minus 1. Now 28 into 8 into 2. 28 into 8 into 2. That means 28 into 60. What is the value? 28 into 60. 28 into 60. Quickly. Yeah, 448. 448 means M equal 44.8 because 10 to the power minus 1 kilogram. 44.8. 8 kilogram. 44.8 kilogram. Okay, they are the exam questions. Very simple. If you, I think, no, you know 100% theories, only need to practice, apply for questions. The question, you have to continuously practice questions now. Okay, next question. Next one easy. Second one, state an advantage and disadvantage of using each type wire. Okay, what are the advantage of using copper? Copper, normally in our house wiring systems, normally we use copper wires, no? House wiring systems are ගෙදර දාලා තියෙන copper wires. But in transmission systems, long distance transmission systems, ඔයාලගේ පාරවල් වල මොනවද දාලා තියෙන්නේ? Aluminium cables. Okay, what are the disadvantage and advantage? Okay, if you got copper, they are very important. If you got copper wire, the main advantage, remember, it frictionless, not friction, it's the resistance, sorry. The resistance very low resistance, comparatively low resistance. Low resistance mean energy lost very low resistance. The heating lost very low resistance. Okay, what is the disadvantage? Main disadvantage of copper wire, they are highly expensive. That's the main disadvantage. They are very low resistance but expensive, very expensive. Maragana. Let's take aluminium. What are the advantages? Anyone? Now, මේ දෙකම අනිත් පැත්තට ලියන්න පුළුවන්. Opposite side. Yeah, less expensive. That's the main advantage. That's why we can use long distance transmissions. Less expensive. Okay, what are the disadvantage? It has comparatively high resistance. High resistance. Okay, they are the answers. Comparatively high resistance. Okay, that's all about copper. That's all about aluminium. Okay, clearly note down. Okay, next Wednesday I'm going to start a new lesson. Make a electricity wala we have tutorials, no? I hope to get extra classes when I free and complete this electricity parts, electricity practice questions. Then from next Wednesday 25th, I'm going to start statistics, our new lesson. Okay, second part done. The following table show the power of electric equipment, number of equipment used and the number of hours used daily in houses. If the cost for 1 unit of electric power. That means 1 kWh is 20 rupees. Yeah, last day I explained one electric unit, in 1 kilowatt hour. That is 20 rupees. Calculate. Okay, 11, 8 into 5, 40. 8 into 5, 40. 40 into 11, 440. Use calculator and check my answers. 440. 440 into 3. 440 into 3. 1320. 13.2, right? Please check. Am I correct? Tanya? Is it 13.2? Check, check, check. Fatima, correct? I'm asking about me. Am I correct? Mama hurry. Because I'm doing without calculator. You have calculator? Okay, fan. Fan. 50 watts. 50 divided by 1000 to convert into kilowatt. How many fans? 5 fans. 5 fans. Sorry, 5 fans. 5 fans. How many hours? 12 hours per day. How many days? 30 days. 0 to 0, 0 to 0. 6, 30, 30 into 3, 90. Am I correct? 90. Please check. Refrigerator. Refrigerator. What is the power? 70. 70 over 1000 to convert into kilowatt. How many? 1. How many hours? Refrigerator? Yeah, entire day. 24. 24. 30 days. 0 to 0 to 0 0 cancel out. I need help for this one because 24 into 1, 24. 50.4. Is it for refrigerator, Samia? Yes, 50.4. 50.4 kWh. Okay, kettle, kettle. 1,500 over 1,000. 1,500 over 1,000 into 1 into 1 hour, 30 days. 30 to 30 cancel out. 15 into 3, 45. 45 kilowatt hour. Kilowatt hour. Okay, without calculate, can you send make a mark here? Oh, our iron 9, 750 over 1,000 into 1 into half into 30. What is the value? For iron, 11.25 kilowatt per hour. 11.25 kilowatt hour. Now you can get the summation of all electric units. Okay, now you can add those all electric units. 13.2 plus 90 plus 50.4 plus 45 plus 11.25. 209.85. 209.85. 209.85 into 20, because per 1 unit 20 rupees. Then what is the electricity bill of month, 30-day month? Multiplied by 20. 4,197 rupees. 4,197. Okay, that's a one question. 7.5 marks from 100. Very simple, right? Okay, any doubt? Any doubt in 2015 question? All clear? Please send message. Tanya? Dehni? No. Okay, let's move into MCQ questions. MCQ. Good tutorial number. Tutorial number 2. Okay. As shown in the figure, two wires of aluminium and copper. Again, asking about aluminium and copper. This is past paper questions all. These MCQ past paper questions. As shown in the figure, two wires of aluminium and copper with same cross section area and length are connected to each other to let the current flow. The true statement regarding each wire is equal voltage drop across two wires but different current flow into them. Okay. Equal voltage, different current. Is it correct? Now aluminium and copper series, no? It's a series system. Now same current is flowing. Same current is flowing. That's wrong. That's wrong. Same current is flowing. That's wrong. No current. Equal voltage drops across two wires and equal current flowing through the equal current flowing through the. No, not equal. How about resistance? Aluminium and copper with same cross section area and length, same length, are connected to each other. No, equal voltage, no equal voltage. Always series systems, voltage dividers, not equal. Make a වැරදි term එක මම underline කරන්න. Equal voltage wrong. Equal voltage wrong. Second question, equal voltage wrong. Voltage dividing. Different voltage dropped across two wires, but equal current flow through them. Very good. Question answer number 3. Different voltage drops across two wires and different currents, no different currents. The rate of heat dissipation of each wire is equal. No, the resistance difference. No, the resistance differs because equal length and equal cross section area, but the resistivity difference. Therefore, it has two resistance. Therefore, the rate of heat dissipation not equal. Answer number 3. Answer number 3. Answer number 3. Yeah, they are very important questions and very good questions. Who correct this? I told to complete them as homeworks. Abir correct? Fatima, Tihini correct? Good. Tanya, Harid? Okay, question 2. Question 2. The number of turns of the primary and secondary coil, last equation, of a transformer is 500 and 125 respectively. When 240 alternative voltage is supplied to the primary coil, the output voltage of the secondary coil is. Okay, what is the what is the type of this? Can you identify it is step up transformer or step down transformer? Quickly send me. The number of turns is given. Primary and secondary 500 and 125. Step up or step down? Samya. What is the type of the transformer? Quickly. Last day lesson. Is it step up or step down? Fatima? Definitely, it is step down because the secondary coil turns less than the primary coil. Step down, voltage decreasing, voltage drop resistant transformer. Okay, the number of turns primary and secondary 500 and 125. Oh, sorry. Okay, what is the equation? The Vp over Vs equal Np over Ns, same side, no current involvement, Ns. Then Vp don't know, the 500 and 125. Vp primary voltage is given. Primary voltage is given. Primary voltage, when 240 voltage alternative supply to the primary coil, the output voltage of the secondary coil. That's exam question. 240 Vp. Then the way Vs is asking. 0 to 0 cancel. Now Vs equal 24 into 125 over 50. Over 50. Vs equal, what's the value? 2 and 9. 2 to 12. 12 into 9. 108 volts. 108 volt. Oh, sorry. Then mistake. Oh, sorry. It is not 9. 25, 5, 5. Sorry, it's 60. Mistake. 60 volt. Answer number 1. Okay, understood. Okay, question part 3. Question number 3. Exam MCQ question number 3. The variation of electrical resistivity. The resistivity means rho, that you already know, right? With temperature for three type of conductors are shown in the given figure. Given graph A, B and C. The conductors corresponding to the graph A, B and C in order is. Okay. Now you already know, according to theory lesson, what is this? They are superconductors. Now this temperature we called as critical temperature. No? Critical temperature, CT, critical temperature or transition temperature. Okay, that's the temperature. Okay, normally if you can remember, superconductors are special conductors. When decrease the temperature, resistivity is decreasing. Resistivity decreasing. When it is come to a certain temperature that we call as critical temperature, what happened? It's take into zero. That's why we call as superconductors. Superconductors. Okay, no need to think that is a superconductor. Superconductor. And now, what is the first graph? First graph, when increasing the temperature, the resistivity decreasing. The resistivity decreasing mean, how about the conductivity? Resistivity decreasing mean, what happened to the conductivity? The conductivity mean reciprocation of the resistivity. The conductivity mean reciprocation. The conductivity mean 1 over 1, 1 over 1 over. I think you can remember. Now, when increasing the temperature, the resistivity decreasing. The resistivity decreasing. That means the conductivity increasing. What are the conductors? Semiconductors. Semiconductors. When increase the temperature, the conductivity increasing, resistivity decreasing. Semiconductors. Okay, full theory, no? Full theory. Okay, when increase the temperature, the resistivity increasing. That means conductivity decreasing. I told you, normal conductors. Conductors, when increase in temperature, what happened due to vibrations and due to disturbance, the resistivity increasing, the conductivity decreasing. Do you remember? Now you can select easily. The first one, semiconductor. Fourth or fifth answer. Middle one, superconductor. Final one, metallic conductor. Understood? Sarnya? Yeah, several times in the lesson I explained about it. Do you remember? Habib? Correct? Tanya? Dihini? Fatima? Okay, question 4. An ideal transformer. I told the ideal mean the this ideal meaning it's a theoretical term. In practically we don't have ideal transformers. Last week I explained. Ideal transformers mean transformer without any energy loss. In practically they don't have, but theoretically for our calculation purpose we use these terms. Has 100 turns in the primary coil and 200 turns in the secondary coil. They are exam question, okay? Very simple. When the primary coil is connected to 120 voltage alternative supply, it's give 10 ampere. Then the voltage of the secondary coil is voltage over current of the secondary coil is then the voltage over current of the secondary coil is. Okay, how to calculate? Ideal transformer equation you already know, right? Now I'm going to note down first this. First note down this given data. Ideal transformer has 100 turns in the primary coil and 200 turns in the secondary coil. Then NP 100, NS 200, 2 times. When the primary coil is connected to 120 volt alternative supply, that means VP equal 120. VP equal 120 volt and IP is given 10 ampere. They are the data. Okay, according to basic equation, our basic equation, VP over VS equal NP over NS. NP over NS. First, we can calculate the secondary voltage, no? VS. Secondary voltage. Okay, what's the secondary voltage? VP value is given 100. VS 100. VS we don't know. NP 100 over 200. Now 0 to 0 cancel. VS equal 200 volt. 200 volt. Now the second part, they ask what is the current also. Then you can calculate the VP over VS equal IS over IP. Reciprocation, okay. For only current, the side is changing. Make a marvel, no? Hurry. IS over IP. VP. The VP and VS now you already know 100 and sorry, VP 120. Sorry, there is a mistake here. It's 120, no? It's 120. 120 over 2, 120 into 2, 240. Sorry. 240. 240. VP 120. It's 240. Equal IS don't know. Secondary current we don't know. Primary current is given 10 ampere. 10 ampere. 20 cancel out. IS equal 120 over 24. Can you send me value? 120 over 24. It is 6, no? Is it 6? Ah, 5. Yes, 5. 5 ampere. 5 ampere. Now the question asks VS over IS 240 over 5 ampere is the answer. This is answer. 240 volt over 5 ampere. 240 answer number 2. See, if you know the basic concept, easily you can apply into questions, and if you have more practice within given time, easily you can apply this basic concept into questions and you can get the answer. Very simple. Don't panic and confuse due to electricity question. You have to keep your practice continuous. You have to practice these questions. Okay, BST students, now you can join the BST class. Okay, let's get another extra class to discuss other questions. You have to complete. Okay, please complete all questions and let's take another 1 hour. Podi time margin make electricity. And next Wednesday I'm going to start. Tomorrow we have time. Okay, let's discuss tomorrow. Tomorrow evening. Then next Wednesday I'm going to start the statistic lesson. Okay, now you can join with your classes. Goodbye.